Today, let us start with a photodiode and a light emitting diode. The first thing, let me start with the photodiode. Normally, the photodiode is a PN junction, so which converts the light energy into electric energy. That is a very important thing about the photodiode. But the light emitting diode, the reverse operation of photodiode means the light emitting diode will convert the electric energy into light energy. So first, let us study about the photodiode. It's a PN junction. It converts light energy into electric energy. It also sometimes referred as photodetector, or sometimes we may call it as photosensor, or we may call it as light detectors. Now the symbol for photodiode will be like this. So it's like a normal PN junction diode only, but what will be the difference in the sense? The first difference is, so the symbol in this symbol, there will be a additional the light will be fall on this diode light. The second is about the biasing. The normal PN junction diode will work only in the forward bias. But to operate this photodiode, you need to operate in a reverse bias. That is nothing but you have to connect this the P type to negative, N type to positive. So this is P type, this is N type. Now the photodiodes are specially designed to operate in reverse bias condition. So it operates, you can make a point, operate in reverse bias. Later we'll see why reverse bias. The reverse bias means the P side of the type will be connected to negative terminal of the battery and the N side is connected to positive terminal of the battery. Next, the photodiode is very sensitive to light. So when light or photons falls on the photodiode, is easily it converts light into electric current. So as I say, photodiode, immediately you can strike in your fall, that is in your mind, that is nothing but we may think about like a solar cell, because the solar cell also will work in the same, because normally the solar cell means the sense we can say it is a photodiode only. So what the solar cell will do, it will detect the light, then it will produce the electric energy. So but the large area photodiodes, because the solar cells also known as large area photo cells will be there. You might have seen the solar cells, it will be like this, will be there. The solar cells will be there. So large number of photodiodes will be there. So it converts the solar energy or the light energy into electric energy, but the solar cells will work only at a brighter light. That is why we can say that this photodiodes, we are not using in more applications. Next, the one of the application of this photodiode, we can say just to count the bottle. So you may say here, this is nothing but a conveyor belt. So here we are having a bottle. Just in a conveyor belt, the bottle is moving over there. You need to count the number of bottles. What is doing here from this side? I'm passing the light. So what happened? So the light will be passing continuing here like this. Okay. So if there is a no object over there, so what happened? It won't count. If any object crosses the light, what happened? The light will get break. Automatically it will count as one. Next object will two, then it will be three. So this and all you might have seen anywhere in malls or any other places. In the there will be a door over there. The people, the pedestrian, they will walk inside. So in the top, you can see there will be a counter machine. What it do here, it will count, like there is a light will be there. So we're passing the light. Just as we enter over there, we'll break the light. Once you break the light, what happens? It will start to count. That is nothing but you can say photo sensor. It will sense the light, I can say, or we can say some motions also. Now, what will be the construction of this working principle of photodiode? Just what we need to do, let us take the diagram of the PN junction diode. Only the same diagram we'll use it. With the help of that, let us study about the photodiode. So now you see this is the figure which shows the photodiode, the construction. In the normal PN junction diode, the voltage will be used as energy source to generate the electric current. Whereas in the photodiode, both the voltage as well as the light are used as energy source to generate the electric current. Here the symbol already we studied, like the arrow that represents this arrow that represents the the striking the diode represents light or photons incident on the diode or in the junction we can see here this only we can say the light, the incident photon. This is nothing but a lights actually. Okay, now from the construction we can say the photodiode has two terminals, that is a cathode and a anode. That is, this is the p type only we can call as anode, then the n type we can call as cathode. A normal PN junction diode allows a small amount of electric current under the reverse bias condition, because as I said earlier, the photodiode will work in the reverse bias condition, but normal PN junction diode will work in the forward bias condition. So here a normal PN junction diode will allow a small amount of electric current under the reverse bias condition. So if you need to increase the electric current under the reverse bias condition, so what we need to do? We need to generate some more minority carriers. So normally what will happen actually? So like during the reverse bias condition, so in the P type will have the minority carriers are electrons, right? Magnetic carriers are electrons. In N type, the magnetic carriers are holes. It will slowly, it will move over there actually. It will slowly, it will move in the sense what happened? It will produce a reverse current actually. Correct. So now what we need to do here? So like we need to generate more minority carriers in the P type as well as in the N type. We need to generate. How we can generate? So it is very simple. Just what we need to do, from the external reverse voltage applied in the PN junction diode will supply the energy to the magnetic carriers, but will not increase the population of minority carriers. So, however, a small number of magnetic carriers are generated due to the external reverse bias voltage. The magnetic carriers generated at the N side and the P side will recombine in the same material before they cross the junction. Slowly it will move. See, slowly it will move. Magnetic carriers, it will move. So it will recombine. So now I can say as a result, so there will not be no electricity flows due to this charge carriers over there, because inside the depletion junction, it will become as neutral. Neutral in the sense the neutral, the normally the neutral here I can say the neutral normally doesn't have any charges. So what will happen? So for example, what you have to do, you need to apply a some force from the external. So that is the reason what we are doing. We are applying a external energy is directly to the depletion region to generate more charge carriers. So because in the forward bias, you will have a narrow depletion region, but in the reverse bias, we'll have the wider depletion region will be there. So if you're having the wider depletion region, so what we need to do from the externally, we need to pass a light. or the photon will be incident on the junction. So here we'll have the neutral elements will be there. So that will be break. So we'll get here some form of the pairs like the holes and electrons will get. So now the special type of diode, only the photodiode, will generate more number of charge carriers in the depletion region. So in photodiode, we use light or photons as the external energy. So to generate the charge carriers in the depletion region. So like here we can say, so nowadays the photodiodes are not widely used. So now if the light energy is applied to photo energy. See here only light energy we are applying is applied to photodiode will be is greater than the band gap of semiconductor material, because you see this will be your conduction band, this will be your valence band, and the conduction band will be empty, valence band will full of electrons. So when you pass a light on this valence band, what will happen? It will jump from valence band to conduction band actually. So this is nothing but a band gap, I can say. So from this simple, we can say it will move, the free electrons will move freely from one place to another place by carrying the electric current. As the light increases, that is what simple as that. So as the light increases, we can say the current also increases. Light means the intensity. The intensity of light is increases. The current also will be increases. So this is nothing but, so from this one more thing I need to say here. When no light is applied in the reverse bias photodiode, it carries a small reverse current. Right? You have to, this point is very important point. When there is no this is one of the important point here. Yes, see, when no light is applied to the reverse bias photodiode, it carries a small reverse current due to external voltage. That small electric current under the absence of light we can call as dark current. You might have studied in your physics that dark current will be denoted as, that is in lambda, that is I lambda. So always we can say in photodiode, the reverse current is independent of, that is IR, I can say, right? Reverse current means IR. IR is directly proportional, so independent of reverse bias voltage, that is VRB, we can say. VRB. The reverse current is mostly depends on the light intensity. So the reverse current is purely depends upon the light intensity. Very, very important, because if the absence of light will yield dark current. So if the light is present, then there will be a amount of current will generate. So now here we can say the total current through the photodiode is the sum of dark current and the photocurrent. The dark current must be reduced to increase the sensitivity of the device. So here we can see the characteristics. You can see here, this will be your forward voltage. See, normally the graph will be like this. Correct answer, because this will be your reverse bias. This is your forward bias. Your photodiode will work in the reverse bias only. See here, as the forward bias, like the input voltage, dark current, absence of light. As the reverse current increases, this will be your illumination. That is actually, as the illumination increases, means the light intensity is increases, the current also will get increased. You see this. So now further, so let me write the wavelength. Or I can say the one more thing here, very simple. The electric current flowing through the photodiode is directly proportional to incident number of photons. So that point is very, very important. So we can make even this point also. Yes, the electric current flowing through a photodiode is directly proportional to incident number of photons. Now let us do something about the wavelength. Wavelength. So now the energy associated with each photon is directly related to the frequency of traveling wave. Determined by the following equation, the wavelength will be defined as W. The W is equal to HF. That will be equation number 1 we can consider. So the unit is joules actually. Yes, the unit is joule. Next here, where what is the H actually? Where the H is nothing but, what is H? Where this H is nothing but it's a Planck constant. What is the value of Planck constant? The value of Planck constant is nothing but 6.624 into 10 to the power of minus 34 joules per second. The frequency is related to wavelength, that is the distance between successive peaks of the wave by following equation, that is lambda is equal to, we'll write the lambda is equal to V by F. You can say this will be unit lambda unit is what actually in terms of unit Armstrong I can say, where 1 Armstrong is nothing but 10 to the power minus 10. 1 Armstrong is nothing but 10 to the power of minus 10 meter actually. Okay, so now let me write lambda is V by F, where what is V actually, where the V is nothing but velocity of light. Velocity of light. So it is nothing but the value will be 3 into 10 to the power of 8 meter per second. Then what is lambda? From this I can say the lambda is nothing but wavelength. Lambda is nothing but a wavelength in terms of meters, we'll say. What about the F? Where the F is nothing but the frequency of traveling wave. Frequency of traveling wave. In hertz, I can say the frequency in terms of hertz. Now what you do, substitute this, you consider as equation number 2. Now substitute this over the lambda. What is F? F is equal to, from this I can say F is nothing but F is equal to, from the above, V by lambda. Then W is H into F. So H into V by lambda. So from this I can say simple, the W is indirectly proportional to wavelength actually. I hope you know. So you can find the energy associated the discrete package of atoms. Like the discrete package of atoms is inversely proportional to the wavelength. So now from this we can say the energy associated with the photons being absorbed by the semiconductor layer of solar cell is a function of wavelength of the incident light. And the longer the wavelength, the less the associated energy levels. So this is about photodiode. Next, let us study about light emitting diode, that is LED, light emitting diode. Now here we can say the light emitting diode. What is only light emitting diode? Very simple. We can say the light emitting diode, it's like it converts electric energy to light energy. That is nothing but a LED. So let me put here. Light emitting diode is electrical energy flowing through is directly converted to light energy. So now how this will be there, the symbol of light emitting diode will be very simple. That is as like simple like your diode only, but the light will be away from the junction. See, it will emit the light. Okay, previously in the photodiode, it will detect the light. This will emit the light. You might have seen so many LEDs like with the different colors. You might have seen yellow color, red color, green color, white LED, blue LED. So many LEDs you might have seen. So you have not seen so many colors. You might have seen the colors of your LED is VGR. I think you might have studied in the physics, like that is the violet, indigo, blue, green, yellow, orange, and red. So out of this, which will have the more wavelength? The wavelength is nothing but the red is the highest wavelength. The lowest is violet wavelength. That is the reason everywhere you can see they used red color, even in the signals or in the towers and all, you might have seen the light of color is red color, because the light visibility during the night, even whichever the long, that like that is the wavelength is very high for a red light. Next it will go for orange light. That is why next is yellow color, that is green color. That is the reason in your traffic control they using red color, yellow color they use, and the green color they use, because these three lights are will be more visible. But see the blue color light B, so that is won't be that much brightness, won't be. It's not based on the brightness, it is like the wavelength, how it will be visible from the longer. That is why you can see, even if you see in the dark area, in the long distance, if you see small red light also, we easily we can identify. But you may ask, then what about the white? Here, the color I talk, the black and white is not a color. Then we will say the black and white, but the color means this is the color, the R, G, and B. Only those things are colors. Now what we'll do, the light is a type of energy that can be released by an atom. So light is made up of many small particles called photons. But you may think in which bias it will work. Very simple. It will work in the positive bias. So it's like a normal. So you may think now, then what will be difference between the normal, the conventional PN junction diode and this LED? You may think. So very important thing here we can say the light is made up of very small particles called photons. The photons have energy and momentum, but no mass actually. So the light emitting diodes are most widely used semiconductor diodes among all the different types of semiconductor diodes available today. The light emitting diodes will emit either the visible light or invisible light, that is invisible infrared light when it is in the forward bias. The LED which emits invisible infrared light are used for remote controls actually. In a remote control, you might have seen those light or the infrared light we cannot able to view that much. So now, so a light emitting diode, that is LED, is a optical semiconductor device they will call, that emits a light when the voltage is applied. As the voltage is applied, it will emit the light. In other words, we can say the LED is a optical semiconductor that converts the electrical energy into light energy. Now, when the light emitting diode is forward bias. So I need to show like the diagram, how it will be in the sense. Say example, let me show this. See, this is nothing but your the structure of the LED, how it will be. So now here in this we can say, like you may think now what is the difference between the normal diode and this LED, this diode, you may think, right? So what is the difference in the sense, like when the LED is forward biased, like when it's a forward bias, the free electrons from the conduction band recombines with the holes in the valence band and releases the energy in the form of light. You see here, which is shown here, that is a recombination of the like your electrons and the holes, like recombination of free electron and the holes that will emit the light, or it will emit the photons. So even here also in the p type. So here you can see in this figure clearly we mentioned here. But here the process of emitting light in response to the strong electric field or flow of electric current is called electroluminescence. Normally, how we'll measure the brightness? To measure the brightness, will so to measure, how we'll measure the brightness? Brightness will be measured in terms of lumens. They will call us lumens. You can see in your LED bulb nowadays what you are using for your household purposes. In that, you might have seen the LED bulb. You might have seen the LED bulb, which is like a 9 watts bulb, you see. So with the different companies they will have. But each and every company light, just you look into something called as like how much the lumens they mentioned. Like say example, I'm saying, like say example, 1200 lumens, or they might have mentioned 1500 lumens. Example, you consider this is the one company called as X company. This is called as one company called as Y company. So now what happened, the S company will sell the 9 watt LED bulb. Example is nothing but 95 rupees in the sense. So these people will say the cost is nothing but 1300. You may think it's a 9 watt bulb only. Then what is the reason? Like it's paying 95 rupees and 130 rupees because of this lumens, you can say. Or some of them, they may have different lumens also will be there. That lumens only will see the amount of brightness, that is 9 watt. So now in this I can say, like a normal PN junction diode, LED also operates only in forward bias condition. To create an LED, the N-type material should be connected to negative terminal of battery, P-type is connected to the positive terminal battery. Other words, N material should be negatively charged, P-type should be positively charged. Now, in this, the construction of LEDs is similar to normal PN junction diode, except the gallium phosphorus. So gallium material, that is Ga, phosphorus PH, right? Phosphorus and the arsenic materials are used for LED instead of silicon or germanium. That is what you may think. What is the difference between the normal PN junction diode? Because you may think normal PN junction also it may uh, produce the light, but no. Only thing is here we are using gallium, phosphorus, and arsenic materials. But still, you may use some different materials to produce different colors. So in the normal PN junction diode, the silicon is mostly widely used because it is less sensitive to the temperature. Also, it allows electric current efficiently without any damage. But in some cases, the germanium is used for constructing the diode. However, the silicon or germanium diodes do not emit energy in the form of light. Instead, they emit So normally what will happen here? The silicon germanium do not emit energy in the form of light. So instead of that, it will emit energy in the form of heat. Thus, the silicon or germanium is not used for to construct the LED. So now here something I will show the diagram like a biasing light. So here the biasing, we done the forward biasing. This is the one resistance required because if I'm not using this resistor, it will limit the current actually. Else your LED may get damaged. The reason just one resistor is connected over there. You can see here the forward current and the light output. See here forward current 90 degrees Celsius, that is 15 degrees Celsius, means the general light output versus the forward current for two temperatures. So like this, we'll have different temperatures. We'll have different colors. Say example, if you want to say like example, say example. So I will show some graph. This is not required actually in examination, this graph actually, just for a purpose I'm giving. See here, this is x-axis is nothing but a wavelength. Y-axis is nothing but your light output. See, these are the visible lights. Which are the visible lights we see here? The one thing is like, this is blue, right? This is blue, this is green, this is yellow, this will be red. Example, this is red actually. So that is maximum 580 to 720 we are having. Wavelength of red, you see, the light output normalization. Now in this, I can say the normalized output of visible red light, the peak at 660 nanometer. See this is that, which one I'm saying, peak at 660 nanometer, where see this 660 nanometer, you can see this, right? So now